Okay, in this video, we're going to talk about repetition structures. So one of the things that a computer really can do well is just to repeat the same lines of code over and over and over again, okay? So you could have something, and the book gives an example. You're calculating commission for salesmen, okay? So you could just have it ask 50 lines of code that say enter salesman's name and then look up the commission or whatever, okay? But it makes more sense to put it in what we call a loop. Okay, we're going to loop around for some reason. Okay, so there are two basic types of loops. The first is a condition-controlled loop. With a condition-controlled loop, that you're going to keep going around and around and around the circle until some condition is met, and then you stop. Okay, that condition that gets you out of it's called the terminal condition. Okay, so you have to make sure in your loops you're always moving toward a terminal condition. The other kind of loop, which we'll talk about here in a minute, we're talking about the condition control first, is a count control loop. A count control loop is just going to go 100 times or some number of times, okay, not depending on whatever condition is going on. So we're starting out here with this idea of a condition controlled loop, which in Python and in C++ as well, although the syntax is a little bit different, it's called a while loop, okay? So here's what the flowchart looks like, and this should be a regular arrow. It just wasn't letting me select that for some reason. The program has sequential code or whatever comes into this loop. It's going to check the condition. Is x greater than 100? Whatever a Boolean expression that returns true or false. True is going to execute one or more statements here, and then go back and check the condition again. It's going to keep doing this until this condition becomes true. When this condition becomes false. When this condition is false, it kicks you out of the loop and it goes on, okay? So there's the possibility that these statements will never be executed. If the condition is false the first time you hit it, this never gets executed. So we have to make sure that we get to that if that's what we're trying to do, okay? And in code, we have a while, some condition, okay? This conditions, and whatever we've done inside of an if statement, should spell condition wrong or spell it correctly. There we go. So this condition could be greater than, less than, or equal to. It could, you could have ands or ors or nots around it. Okay, and then again, there's the colon at the end, and then there's the indentation that shows that you're in in this structure. Okay, so as soon as you're out to here, you're now out of that condition, okay? And you're now down here, okay? So let's take a look at what this looks like with an actual coding example, how it could be helpful to us, okay? So share the correct screen here. Okay, so let's do a real simple example. We're just going to print the numbers 1 through 10, okay? So we're going to start with, we have to set the initial value that's going to make it into our loop. So let's just say x is equal to 1, okay? Now I'm going to say while x is less than or equal to 10, okay? Print x. That's all I'm going to do. You run this, and once it fires up, it goes into an infinite loop. That was not what I meant to do, but I'm glad I did. It should, why is it not stopping? Stop. I'm gonna stop it here. Infinite loops are a problem. And I had quite a big one. It can eventually cause your server to shut down temporarily after we restart it. Didn't go that far. Okay, so here's what I'm missing. Okay, if I can ever get back to the top. There we go. Okay, so I'm gonna kill this. Kill that. Yes, okay. So here's the problem. Here's what I'm doing. I'm setting x equal to 1. I'm saying, is x less than or equal to 10? Yes, print. It then goes back to the while and goes around and around and around forever. So what I needed here was x is equal to x plus 1. Okay? Or you could write that if you prefer, x plus equal 1. Means the same thing. If I run it now I get what I wanted. Okay? So again, I said it, but I didn't follow by it, that every while loop has to move toward the terminal condition. Okay, so I start with x being 1. I'm moving toward X being 11. So inside of the while loop, I have to make sure that I add 1 to it every time. Okay. So that's the basic idea. Okay. There's not too much else to do with that. I mean, we can use it in some different examples. As you read through the book, it does give you some different ways that you can do. And we're going to do some in class for sure. But anytime you need to repeat something until something else happens, okay, that's when you're going to use this while loop. Okay. So the other kind of loop we have is a for loop. A for loop is called a counting loop. Okay. So a counting loop is one where you know how many times that you want to do something. Okay. And on the syntax of this one, we could do the following. We could say for, so it's for is the keyword here. Num in, I'm just going to put a list of numbers. 1, 2, 3, 4, 5. Okay. Colon. Okay. So this in the brackets is a list. It's a Python list. We'll get to those later. It's a very powerful feature of Python. Okay. So with it, this is going to be what we call an iterator. It's going to iterate through. So the first time through, num's equal to 1, and then num's equal to 2, and then num's equal to 3, and then 4, and then 5. Okay, so this, it doesn't matter. We don't have to test anything on that. Okay, in fact, I can just go inside of here, make sure I tab over, and print num. Okay, and we can see what's going on there. It goes from 1 to 5. Okay, so if you want, you could always use a while loop. Okay, it does pretty much everything that you want it to do. But the for loop gives us some options, and it's a lot more efficient when you're dealing with consecutive groupings of numbers. Okay. So that's the main thing to do there. The other thing we can do with this, there's a function built in, and I think I can just do this here, a range function. And what the range function does, it's going to return a series of numbers. Okay. So if I say range 5, it didn't really do anything. Well, it gives me the numbers between 0 and 5, but let's go through this way. So let's try to test it this way. I don't have the ability to do a command line thing for this for whatever reason. Okay. So let's do for num in range 5. See what that does for us. Print num. Okay. So notice that the range is going to return a string of numbers starting with 0 and going up to, but not including the top number. Okay. So if I wanted to modify that and make that a 15, goes from 0 to 14. Okay. So I have some other options here. I can put in a starting number that's not 0. So if I don't put anything, it assumes that it's a 0. Okay. So if I want to put other things, okay, the range can take up to 3 values. It can do, it's like 1, 16. Okay, let's see what this does for us. Okay, it now starts with the number 1 and goes up through 15. 16 minus 1. You can do that with a 10 if you want. It's okay. Okay. You should be able to do this with a negative number, negative 6. Yep, all that's okay. All that's fine. Okay. So if you don't have anything in the range, it assumes a starting point 0. But if you have a comma, then the first one is the first number, and the second one is the second number. Okay, is the end. So sorry, we say that again. The first number is where you start. The second number is one more than you end with. Okay, so it goes up to, but doesn't include. Okay. There's a third option we could put in here. Let's say I put in 0. I don't have to, it defaults to that. Say I go to 40, and the third number is 2. The third number here is called the step. Okay. And what that will do, it will increase by that amount every time. Okay. So I do 0, and then it does 0 plus 2. So this gives us the even numbers, basically. Okay. And I can do other things with that for sure. Okay. So let's take a look at one program from the book. This is program 4.8. Okay. It's going to use a loop to display a table showing the numbers 1 through 10 and their squares. Okay. So we're going to start off here. We're going to print the table headings. Okay. So here we've got print a number. We're going to use that \t tab character. I'm going to put square. Okay. Just to see that, make sure that's working all right. Well, I've got number, we've got square. Pretty straightforward. Okay. And now we're going to just print a line here just to make it look nicer. So I'm putting some underscore characters or some dashes, whatever you want. Let's do just regular dashes. Okay. Now we've got that. Now we're going to print the numbers 1 through 10. Okay. And their squares. Okay. So I'm having my for loop here for number in range. I want to start at 1. I want to go up to 10 plus 1 is 11. And the step being 1 is fine. I want to hit every number, hit a colon. Okay. It's going to indent me over. I'm now going to say the square is equal to the number exponentiation star 2. Okay. I'm then going to print the number, a tab key, \t, and that square number. Okay. So if I've done all that correctly and I run it, you get the numbers from 1 to 10 and their squares. Okay. So all pretty straightforward. One other thing that we can do that the book mentions is that we can go through a list of strings. It doesn't have to be anything else. So I can say for name in, did not mean to execute that. For name in, again, the square brackets, Bob, Alice, whatever. Okay. So what name is going to do, then I can just print something like that. Okay. And then it's going to go through name gets the value of Bob, and then Alice, and then Carol. Okay. So that's basically how that's going to work. Okay. And I can do anything with the name variable as I'm going through. Okay. It's also possible, if I can go back enough. Is there a back button somewhere? Yeah, let's do it again. It's okay. So let's say I want the user to do our squares program. Okay. But this time I want them to choose how many they're going to do. Okay. So again, I'm going to print out the number, the tab, square. Yeah, I'm going to print out those dashes. Those need to be in quotes. 1 will do. Okay. But now this time I'm going to say for num in range 1. And then I'm going to create this variable end. And I have to do, let's just leave it at end, see what happens. Okay. So it doesn't know what that is yet. So I'm going to do inputs. I'm going to do end is equal to an int input, enter How many squares do you want? There's a better way to say that. The book has a better, how high do I go? Okay, and then it's going to do that to end. And then before I'm going to print, sorry, do the square. Square is equal to num star 2. Okay. I actually wanted to do cubes. That'd be exciting, wouldn't it? Would be star 3. Okay. And then I want to print out the number, the tab, and this cube. By there and cube. Okay. That's going to print that out. Okay. So let's see if this works. So how high do I go? Say we're going to go to 10. Okay. It's going to go up. So why is it doing the number is being, oh, because I've got the wrong variable. It picked the number from the last time. Okay, so let's do this one more time. Go 10. Now it only goes up to 9, okay, because of the way this works. So I need to modify this and do a +1. And now if I do 100, you see that goes all the way down to 100 cubed. Okay. So that's all there is to it, right? We've got the while loops and we've got the for loops, and those two things are really going to increase the power of our programs for sure. Okay. So if you have questions, make sure you let me know.